Today, we're going to be walking through MDN's A Reintroduction to JavaScript. It is a JavaScript tutorial. The link will be below in the show notes. My name is Caleb Arend. Hello and welcome. This is a blog post for Austin Coding Academy, which is the coding bootcamp I'm going through right now. But today, we're just going to take as much time as it takes to go through this JavaScript tutorial. I'm going to go ahead and share my screen so you can see what we're going to go through. And I'm going to begin with the history behind it. I'm going to try to read through everything and walk through each piece of this with you. So if you want to follow along with that link, you're welcome to do so. The overview of what we're going to go through is we're going to go through all the different types that are in JavaScript, so the data types, which include number, BigInt, string, Boolean, symbol. I don't think they get too much into symbols actually in this tutorial, but we're going to go over objects and those different types of objects like functions, arrays. They don't go too much into dates and regular expressions, but they do go into null and undefined. So without further ado, let's go ahead and we'll get started going through this. Okay, the history behind it, a reintroduction. It says, why a reintroduction? Because JavaScript is notorious for being misunderstood. It is often derided as being a toy, but underneath its layer of deceptive simplicity, powerful language features await. JavaScript is now used by an incredible number of high-profile applications, showing that deeper knowledge of this technology is an important skill for any web or mobile developer. It's useful to start with an overview of the language's history. JavaScript was created in 1995 by Brendan Eich while he was an engineer at Netscape. JavaScript was first released with Netscape 2 early in 1996. It was originally going to be called LiveScript, but it was renamed in an ill-fated marketing decision that attempted to capitalize on the popularity of Sun Microsystems' Java language, despite the two having very little in common. This has been a source of confusion ever since. Several months later, Microsoft released JScript with Internet Explorer 3. It was a mostly compatible JavaScript workalike. Several months after that, Netscape submitted JavaScript to ECMA International, a European standards organization, which resulted in the first edition of the ECMAScript standard that year. The standard received a significant update as ECMAScript Edition 3 in 1999. The fourth edition was abandoned due to political differences concerning language complexity. Many parts of the fourth edition formed the basis for ECMAScript Edition 5, published in December 2009, and for the sixth major edition of the standard, published in June 2015. Since then, a yearly edition has been published. For example, the 13th edition was published in June 2022. No, because it is more familiar, we will refer to ECMAScript as JavaScript from this point on. And so from that point, they don't refer to ECMAScript anymore, but they just call it JavaScript. Unlike most programming languages, the JavaScript language has no concept of input or output. It is designed to run as a scripting language in a host environment, and it is up to the host environment to provide mechanisms for communicating with the outside world. The most common host environment is the browser, but JavaScript interpreters can also be found in a huge list of other places, including Adobe Acrobat, Adobe Photoshop, SVG Images, Yahoo's widget engine, server-side environments such as Node.js, NoSQL databases like the open-source Apache CouchDB, embedded computers, complete desktop environments like GNOME, one of the most popular GUIs for GNU or Linux operating systems, and others. So before we get into the overview, I also do want to say that I have not created any of this content myself. I am in no way the creator of this content. I'm not claiming that I am. I am only simply just doing a walkthrough of the content that's freely available here at MDN Web Docs. They are the creators of this content and the owners of it. I'm simply reading out loud what they have freely posted on the internet for anybody and everybody to see. So getting into these data types, like we just said, we're going to go over, and a basic list is number, BigInt, string, Boolean, function, object, and symbol. A more broken down list is breaking down these functions, arrays, dates, and regular expressions underneath the object category within this list. It says, let's start off by looking at the building blocks of any languages, the types. The JavaScript programs manipulate values, and those values all belong to a type. JavaScript types are as follows, just like we just read. It says the overview, which I skipped, is JavaScript is a multi-paradigm dynamic language with types and operators, standard built-in objects and methods. Its syntax is based on the Java and C languages. Many structures from those languages apply to JavaScript as well. JavaScript supports object-oriented programming with object prototypes instead of classes. And you can see more about that prototypical inheritance and ES2 2015 classes with those links. JavaScript also supports functional programming because they are objects. Functions may be stored in variables and passed around like any other object. We'll see later down at the bottom of this tutorial also that functions I think they can be have methods attached to them, and which those methods then can be used with the dot operators. We'll look at that later. And there are some built-in error types as well. Things are a lot easier if we stick with the first diagram, however, so we'll discuss the types listed there for now, and I think they go in order. So the first data type we're going to go over is numbers. ECMAScript has two built-in numeric types, number and BigInt. The number type is a double precision 64-bit binary format IEEE 754 value. Numbers between negative 2 to the 53rd minus 1 and between positive 2 to the 53rd minus 1. And where this article and other MDN articles refer to integers, what's usually meant is a representation of an integer using a number value. But because such number values aren't real integers, you have to be a little careful. For example, they say that if you print out with console.log 3 divided by 2, it is a number data type, not an integer data type. It returns the value of 1.5, which is a float, which is supported by this number data type. And it's not just one. You would then have to use console.log math.floor 3 divided by 2, which would force it down to 1, the floor of that division, instead of just holding the 1.5. So an apparent integer is in fact implicitly a float. Also watch out for stuff like 0.1 plus 0.2 is equivalent to multiple zeros and then 4. In practice, integer values are treated as 32-bit integers, and some implementations even store it that way until they are asked to perform an instruction that's valid on a number, but not on a 32-bit integer. This can be important for bitwise operations, which is a little bit beyond the scope of this tutorial. So we're just going to keep on moving. The standard arithmetic operators are supported, including addition, subtraction, modulus, or remainder, arithmetic, and so forth. There's also a built-in object that we did not mention earlier called math, that provides advanced mathematical functions and constants. And so, like they were just saying, you can use the plus operator, the minus, the division, and the multiplication operator as the asterisk, as well as the modulus operator. But there's also advanced methods that you can use with the capital M math dot and then method syntax here. So math dot sign, and then calculate with a 3.5 in that sign method. You can also use math.pi to refer to the pi values. I forget what the extent is that it goes out to for those the floating side, decimal side for that math.pi. But if we go to the terminal here in VS Code, and if we create a new file and just call it test.js, and then code test.js, and then open that up. Yes, I trust myself. Okay, so if we use math.sign and we put that 3.5 in there, and then we console.log it. And I got all this other stuff here. Console.log and then parentheses, add a parenthesis, and then we'll console.log as well, math.pi, and we'll see what it prints out. And so let's see, I think it was node test.js, run that, and we get math.sign, and it's out to a bunch of numbers. And there's pi 3.141592653589793. And so once as we continue to go along here, you can see that you can use these methods in JavaScript. Now, the next ones are parse int, you can convert a string to an integer using the built-in parseInt function. This takes the base for the conversion as an optional second argument, which you should always provide. And it'll tell you why you should always provide that as well. So if you parse int from the string with quotations 1, 2, 3, base 10, it'll output the number 1, 2, 3. If you do so with 0, 1, 0, and then parse int with the base 10, it will return 10, ignoring the first 0. In older browsers, it says strings beginning with a 0 are assumed to be in octal, radix 8. But this hasn't been the case since 2013 or so. So unless you're certain of your string format, you can get surprising results on those older browsers. And so if they ran parseInt in an older browser with a 0, 1, 0, it wouldn't give it a base 10, it would give it a base 8. And if it ran with a 0x10 or 0, quote, 0x10, end quote, it could come back with a 16 value instead of 10. Here we see the parseInt function treat the first string as octal due to the leading 0, and the second string as hexadecimal due to the leading OX. The hexadecimal notation is still in place, only octal has been removed. If you want to convert a binary number to an integer, just change the base to base 2. And so parseInt 1, 1, base 2 returns 3. Similarly, you can parse floating point numbers using the built-in parseFloat function. Unlike its parseInt cousin, parseFloat always uses base 10. You can also use the unary operator to convert values to numbers. So if we want to see some of these, we could copy some of this, copy this into our file here. Copy that one. Let's see, do we just copy this one? Yeah, we did. Okay, so let's go here. We'll copy this one and paste it there as well. And then we'll grab this one down here with the binary and we'll paste that in there as well. And click up here. Come on, work with me. There we go. Put a line there. Console.log, open parenthesis. We'll go down here to the end, and it's all the lines are different now. So put there, and there, and end parenthesis. Now let's run the file again, and we get here, it's converted into, that string is converted base 10, 1, 2, 3, base 10, 1, 0. Here in the file, it's converting the first one with 0, 1, 0. It's not an older browser, so it's not converting it to base 8. It's converting it to base 10, but it is reading the 0x from here, line 7, and it is converting it to 16 instead of base 10 or a 10 value. The 1, 1 parsed into a number instead of binary from binary is read as 3. And so as we're moving on here, those are some of the different data types and numbers and number problems you could run into. If you want to convert a binary number, let's see, we just did that. Similarly, you can parse floating point numbers using the built-in parseFloat function. Unlike its parseInt cousin, parseFloat always uses base 10. And so you don't need to worry about that crossover if you don't provide the base value that you want to be converting into for parseFloat. It always does base 10. But if we look at some examples, I don't think they have an example on here. So why don't we, let's see. We'll copy this text here. We'll use parseFloat. We'll parse a floating string, console.log. Just paste it in there, parseFloat, and what's a string we should parse? Let's do 3.5, just like we did above, and turns it from a string, run it, turns it into a number. There we are. As we are going on, you can also use the unary operator to convert values to numbers. And so that unary operator, the plus sign, with the string 42, converts it into the number 42. And same for the 0, 1, 0 and still base 10, but 0x, it'll still convert it with that base 6. I think it's base hexadecimal, base 16. So as we paste this in here, we'll put in the string unary operator code. And that way we have a little bit of division for the code we're running up here. Run it again, unary operator code 3.5. Okay, so yeah, well, it parsed float there. Oh, okay, that makes sense. We're not actually printing these out down here, so that's why we're not seeing that. Console.log. Put the parenthesis at the end, and then same for this, copy it. Console.log, paste, and then let's run it again. And we get 10, 16. That's where we missed that one. Copy. Console.log. Paste it in there. Run it again. All right, 42, 10, 16. So those are working. We'll comment all that out. So new stuff we run is a little bit easier to see. Well, as we go down here, now we're going to look at not a number. We're also parse int, a special value called not a number, short for NaN, NaN, short for not a number, is returned if the string is non-numeric. And so if they try to use parse int on hello, the string, and then 10, it will not coerce the string into a number, and the number will, of base 10, it can't convert that into a number, and so it'll return not a number. Not a number is toxic, it says too. If you provide it as an operand to any mathematical operation, the result will also be not a number. So if you try to do not a number plus 5, it'll return not a number for the entire operation. You can reliably test for not a number using the built-in number.isNotAnumber function, which behaves just as its name implies. So if we copy each one of these and put it into our editor here, copy and paste and copy and paste, and yeah, let's try to log each one of these. Run that. Just copy this. As we're going through each one here, we're going to try to print each one out so that we can see it. Sorry this is taking so long, but just trying to make sure we can see each of these as they happen. Don't need this one here. And so go up here, just need one here and one here, and then we can run it. Missing, looks like right here. Run that. Okay, it returns not a number, true, false, 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 when it's testing for not a number. And so as we go back to the tutorial, as we're going through, you can reliably test for not a number using the built-in function, but don't test for not a number using the global is not a number function, which has unintuitive behavior. And so if you, instead of using number dot is not a number and test the values, if you keep this number dot part off and then just try to use is not a number, sometimes it will work, but it's for some of these it will not, and so it could be unintuitive. JavaScript also has the special values infinity and negative infinity, so which is very very interesting. it says you can test for infinity and negative infinity and not a number values using the built-in isFinite function. So as we go down here, put a console.log statement here as we print in or paste in these different things. So we'll give a comma here and then comma here. There's infinity, there's negative infinity as we're printing out. If we go to this code here, comment everything out for now. Keep moving on. Oh, deleted everything. Okay, that's fine. Console.log, paste in there. Let's put some commas in as we test it out. And then run it. There we go. False, false, false. 1 divided by 0 for infinity is not finite. Negative infinity is not finite. Not a number is not finite. It is not a number. So note the parseInt and parseFloat functions parse a string until they reach a character that isn't valid for the specified number format, then return the number parsed up to that point. However, the unary or the plus operator converts the string to not a number if there is an invalid character contained within it. So just try parsing the string 10.2 ABC with each method by yourself in the console and you'll understand the difference. So let's try that. parseInt and parseFloat 10.2 ABC. Do that one more time. Console.log and then parseInt string 10.2 ABC, and we'll copy this so that we can use it again, and then parseFloat, that same thing, run that, then we'll try it to console.log another thing here where we're doing a plus operator with the string 10.2 ABC. And what was the other case scenario? Yeah, I think those were each of them. So we'll run that and we'll see that 10.2 in the parseInt, what gets to that 0.2, and it parses it into an integer 10. The float parses it to the 0.2, which is right after the period there, but it just ignores ABC. But the console.log with the unary operator for the string 10.2 ABC says it doesn't do any of it. And so that's what they're trying to say there. For strings in JavaScript, strings are sequences of Unicode characters. This should be welcome news to anyone who has had to deal with internationalization. More accurately, they are sequences of UTF-16 code units. Each code unit is represented by a 16-bit number. Each Unicode character is represented by either 1 or 2 code units. If you want to represent a single character, you just use a string consisting of that single character. To find the length of a string in code units, access its length property. So if we use the string hello and we use hello.length, we get returned 5 as the length, since there's 5 letters, 5 characters there. There's our first brush with JavaScript objects. Did we mention that you can use strings like objects too? They have methods as well that allow you to manipulate the string and access information about the string. So if you just use the string hello and use the dot operator and the method char at and then the index at which you want to look at that string, it'll return the character that's at that index. Char at 0 would be H, char at 4 would be O. And then you use hello and then as the first part of the string, world, and then replace, and then the string that you want to replace, and then the string that you want it to be replaced with, and it returns hello instead of world, it will return hello Mars in the string. You can use the toUpperCase method to turn all of the lowercase letters in the string into uppercase. There are other types. JavaScript distinguishes between null, which is a value that indicates a deliberate non-value and is only accessible through the null keyword, and undefined, which is a value of type undefined that indicates an uninitialized variable. That is, a value hasn't even been assigned yet. We'll talk about variables later, but in JavaScript, it is possible to declare a variable without assigning a value to it. If you do this, the variable's type is undefined. Undefined is actually a constant. JavaScript has a Boolean type with possible values true and false, both of which are keywords. Any value can be converted to a Boolean according to the following rules. And so these are the rules for truthy and rules for falsy. 1, false, 0, empty strings, not a number, null, and undefined all become false. So if any of those things, any of those types are trying to be evaluated in any type of conditional statement, they will return false in that conditional statement. All other values, however, become true or are truthy, or if all other values are evaluated in a conditional statement, they will return true. You can perform this conversion explicitly using the Boolean function. So if you use Boolean and you pass in an empty string into that Boolean function or method, it will return false. But if you evaluate 2, 3, and 4, which is a positive number inside that Boolean, it will return true. However, this is rarely necessary, as JavaScript will silently perform this conversion when it expects a Boolean, such as in an if statement. So you can see that below. For this reason, we sometimes speak of true values and false values, meaning values that become true and false, respectively, when converted to Booleans. Alternatively, such values can be called truthy and falsy, respectively. Boolean operations such as logical and with 2 ampersands, and logical or with 2 of the straight characters, those 2 vertical line characters, and then a exclamation point as a logical not. This is also called a bang operator as the exclamation point. Those Boolean operators are supported, you can see below. So variables. New variables in JavaScript are declared using one of 3 keywords: let, const, or var, if you pronounce it that way. The var keyword for creating and defining a variable is not being used quite as much, and we'll see soon why. Now, most coders are using let and const. Let allows you to declare block-level variables. The declared variable is available from the block it is enclosed in. And so let a to declare the variable a, and let name equals Simon is how that syntax is used. The following is an example of scope with a variable declared with let. And so if the comment my let variable is not visible out here, because this is global scope right here, but let uses block scope. So they have a for statement for let my variable equal 0, evaluate my let variable is less than 5, and then the incrementer, my let variable plus plus, and then my let variable is only visible in here, because this, within that for loop, is the block level scope that my let variable is visible inside it. And then it goes outside back to global scope, and then that variable is no longer visible. Const allows you to declare variables whose values are never intended to change. The variable is available from the block it is declared in. So just like let, it has block level scope. If it was declared inside here, it would be visible inside here, but not visible at global level. If they declared const pi is equal to 3.14, pi, and then try to set pi equal to 1, it will throw an error because you cannot change a constant variable. Var does not have the restrictions that the other 2 keywords have. This is because it was traditionally the only way to declare a variable in JavaScript. A variable declared with the var keyword is available from the function it is declared in. So they could use var to set a as a variable with the name a, and then var name equals Simon. An example, and that's the syntax for it, an example of scope with a variable declared with var is shown here. My var variable is visible out here in global scope. And even though it's declared inside the for statement, the for loop, var, my var variable equals 0, my var variable is less than 5, and then increment it. My var variable is visible to the whole function, and then outside here in global scope, it's still visible out here as well. This is why programmers are leaning away from using var to declare variables now. If you declare a variable without assigning any value to it, its type is undefined. It's not null, it is undefined. And that's the difference between the two different types. You can set something equal to null, and the code will understand it as intentionally empty. But if it's something is undefined, it will just say that it doesn't even know what type to declare this as, and so it is type undefined. An important difference between JavaScript and other languages like Java is that in JavaScript, blocks do not have scope. Only functions have a scope. So if a variable is defined using var in a compound statement, for example, inside an if control structure, it will be visible to the entire function. However, starting with ECMAScript 2015, let and const declarations allow you to create block-scoped variables. Next are operators. JavaScript's numeric operators are plus, minus, multiplication, division, and modulus, which is the remainder operator. Values are assigned using the single equal sign, and there are also compound assignment statements such as plus equals and minus equals. These extend out to x equals x operator y. And the example they have here is x plus equals 5 is the same as x equals x plus 5. You can use also the incrementer and the decrementer, the plus plus and the minus minus respectively, to increment and decrement respectively. These can be used as a prefix or postfix operators. The unary or plus operator also does string concatenation. If you use the string hello, use the unary operator, and then the string space world, it combines to hello world as a combined string. If you add a string to a number or other value, everything is converted into a string first. This might trip you up. So if you use the string first, and then +4, and then +5, it will convert 4 and 5 into a string and then combine them in concatenation here to 3, 4, 5 as a string. But if you use 3, the number 3, plus the number 4 before trying to combine them into a string, the addition will take place first, resulting in 7, and then it will convert 7 into a string to concatenate it with 5, resulting in the string 7, 5. Adding an empty string to something is a useful way of converting it to a string itself. Comparisons in JavaScript can be made using the less than, greater than, less than or equal to, and greater than or equal to. These work for both strings and numbers. Equality is a little less straightforward. The double equals operator performs type coercion if you give it different types with sometimes interesting results. So if you give it the number 1, 2, 3 with the double equals sign allowing type conversion, and give it the string 1, 2, 3, it will return true, as in it evaluates the number compared to the string, coercing the string to the number and the number to the string, it will return true. If you give it a number and say, is it equivalent to true, using type coercion, JavaScript will return true. To avoid type coercion, if you want the evaluation to be very strict to exactly the same, is this exactly the same as this, use triple equals operator. 1, 2, 3 as the number, and with the triple equals equivalent operator to the string 1, 2, 3 returns false. It is not equivalent. The same with is 1 strictly equivalent to true, and the evaluation is false. There are also the bang operator with equal sign, the not equal to, and strictly not equal to operators. JavaScript also has bitwise operations. If you want to use them, they're there. Bitwise operations are beyond the scope of this tutorial, so we're going to keep moving. Now, looking at control structures. JavaScript has a similar set of control structures to other languages in the C family. Conditional statements are supported by if and else, and you can chain them together if you like. So, declare the variable name is equal to the string kittens, and then they use strict equals to check if name is equal to puppies. If it is, they'll add and concatenate woof onto the name. Else, if name is strictly equivalent to kittens, then they'll concatenate meow onto name. If neither one of them evaluate true, then they'll look at name and they'll add the exclamation point to it. And then this evaluates to, since name is equivalent to kittens strictly, it will add meow onto it and return kittens meow. JavaScript has while loops and do while loops. The first is good for basic looping. The second is for loops where you wish to ensure that the body of the loop is executed at least once. Before we move on, we'll look at this code for the if statements here. Delete that, paste it in here. And there's no console.log statement, so we will console.log what name is, and then we will also copy and go to the beginning of this line here, paste this in here, and then we will evaluate this to true or false first. Run the code. It evaluates to true. Name is equivalent to kittens meow, and the string prints out from the name variable kittens meow. So as we go on here to now looking at the while loop, this will result in an infinite loop. If you want the evaluation to be performed first and then the code, if the evaluation is true, use while and then the evaluation and then the code. If you want to perform part of the code first in the first iteration, then have the evaluation, whether it should be performed again, you use do, code, and then while. So we can paste this in here. This would be an infinite loop. While true is always true, so it will always run, and we're not going to go into an infinite loop right now. So let input, and then let's say input is equal to 1. And while, then as we get in here, we will set, let's see, input is set to get input. While input is not valid, let's change that. Well, let's try it first. And we will console.log here so we can see what's going on in here, what input is. So now let's run the code. Get input is not defined. And so we will change this to input plus plus. We'll just increment and then we'll print out what input is. And we'll say while input is less than 5, we'll increment and then print it out. It prints out, and since it increments before printing, it increments to 2, 3, 4, 5, prints that out and evaluates, and then it ends when the evaluation of the input is greater than 5 or equal to 5. JavaScript's for loop is the same as that in C and Java. It lets you provide the control information for your loop on a single line. And so here it's using the for loop keyword, and then inside the parentheses, it defines the variable it's going to use as the incrementer and evaluation. Let I equal to 0, a semicolon, then the evaluation, I is less than 5, then a semicolon, then the incrementation, I plus plus, and then the code that will be executed right after the evaluation. JavaScript also contains 2 other prominent for loops, for of and for in. For of uses the for const variable value of array and then do something with the value. And for in, for const variable property in the object, do something with the object property. Let's go ahead and let's test a couple of these. Select all the code, paste it in. Here we go. We will, we don't have an array, so we'll make one real quick. Let's say array 1 is equal to array of 1, 2, 3, 4, 5. And then we say for each value of array 1, console.log value. It prints out 1, 2, 3, 4, 5 of the array for all the things that are in the array. Now, as we go into here, we for const property in object, we're going to use this with an object. So let's try that. Let's say let obj1 obj equals object where let's say name equals to the string Bob. Let's say day is equal to Monday. And let's see if we can print that out. For each property in the object, console.log property is space property. And let's see what that runs. Object is not defined. Const property in object. Okay, that's because we didn't change this to the variable obj. Let's try that again. Property is name, and then property is day. And then we can, let's see if we can property dot value. Access each of those values as well. Property is name, undefined. Property is day, undefined. Okay, so we're not quite able to access that. Let's see if we can do it. This. Nope, still not. Okay, we're going to keep moving on. That's something we can come back to later. The double and double line for or operators use short circuit logic, which means whether they will execute their second operand is dependent on the first. This is useful for checking for null objects before accessing their attributes, or for caching values when falsy values are invalid. So this evaluation, if they set the variable name is equal to O and O.getName, it will short circuit this logic if O.getName, if O is falsy, then O.getName will short circuit. This won't run. And so the getName function or method will not be set to name. Or for caching values, when falsy values are invalid, const name equals cache value or cache name equals getName. So if cache name is truthy already, there's something stored in there, then that will run, and cache name equal getName will not run. But if there's nothing stored in cache name and it returns falsy, then the other side will begin to evaluate, and cache name equals to getName method will run. And so it will store that getName method in the name variable and whatever is returned by that method. The JavaScript has a ternary operator also used for conditional expressions. And so here they declare the variable allowed and set it equal to the evaluation of is age greater than 18. And if it evaluates to true, yes will be stored in the allowed variable. If the evaluation returns to false, then no will be stored in the allowed variable. The switch statement can be used for multiple branches based on a number or string. So switch statement, evaluation or action, and then for each case, if this case is true, then this code will run, and then the break statement will stop it. If this case is true and this is false, then this case will run, this code will run, and this break will stop it. If neither one of these evaluate to true, neither one of them will run, and then the default case will take over, saying the do nothing method. If you don't add a break statement, execution will fall through to the next level. This is very rarely what you want. In fact, it's worth specifically labeling deliberate fall through with a comment if you really meant it to aid debugging. And so for this switch statement, it uses the evaluation for A, and for case 1, it doesn't have a break statement. So it'll if it evaluates true, it'll run, and then it'll run to the next case as well. And then this code will also run, and then the break statement will stop it. Or if neither evaluate to true, then default case will run doing do nothing. The default clause is optional. You don't have to use it or have it. You can have both expressions in both the switch part and the cases if you like. Comparisons take place between the two using the strict triple equals operator. So if we use the switch 1 plus 3 and then use case 2 plus 2 and the yay method and then break, or the default never happens, we can copy and paste this into our code here and evaluate it. So we'll say yay console.log yay, and if default happens, console.log default. Yay is not defined. So let's comment both of these out since we don't have those methods actually defined that we can refer to. And this evaluates is 1 plus 3, which is 4, equivalent to 2 plus 2, which is 4, and that evaluates true, and so yay gets printed out to the screen. Next is objects. JavaScript objects can be thought of as simple collections of name-value pairs. As such, they are similar to dictionaries in Python, hashes in Perl and Ruby, hash tables in C and C++, hash maps in Java, and associative arrays in PHP. The fact that this data structure is so widely used is a testament to its versatility. Since everything, except for core types in JavaScript, is an object, any JavaScript object program, any JavaScript program naturally involves plenty of hash table lookups. It's a good thing they're so fast. The quote string name part is a JavaScript string, while the value can be any JavaScript value, including more objects. This allows you to build data structures of arbitrary complexity. There are two basic ways to create an empty object. The first is with declaring a variable and then setting it equal to a new object with the capital O object parentheses method, object method. And the other way is const variable object, or obj, equals an empty object. These are semantically equivalent. The second is called object literal syntax and is more convenient. This syntax is also the core of JSON, JavaScript object notation format, and should be preferred at all times. Object literal syntax can be used to initialize an object in its entirety. And so they use the const variable declaration, const obj equals to name is string caret underscore for the key is equal to the value of string max, details is equal to another object, and then color is set to orange, size is set to the value of 12. And notice the commas that separate each of the values inside an object. Attribute access can be chained together also. So accessing the color inside the object details inside the object obj results in orange. Using the square brackets and the string names for each of the keys, obj, key details, and then square brackets again, key size results in the number value that's inside size 12. And the following example creates an object prototype, person, and an instance of that prototype, you. So for this, we can copy this code and paste it in here. And we can console.log and console.log u. And if we console.log after that, u.name, it should return u as well. So we print that out, and it prints out the person, which is the object of name with the value of u, and the key of age with value 24. And if we access directly object.name with the assigned to the u variable, u.name returns the string u. We go back to here, we keep going, Once created, an object's properties can again be accessed in one of two ways, which, by the way, we didn't go over the code of how this works. This creates a function, and this calls what the function is named person, takes in two different parameters, name and age, and creates an object with the this dot name operator, setting the key name equal to the value of name that was passed into the function, and this dot age with the key age for the object being equal to the value of the age that was passed into the function as well. Once created, an object's properties can again be accessed in one of two ways, which is the dot notation, where you can access dot name, where name is the key value or the key for the value, and set that. You can also set that equal to using this same notation, and then also setting a variable equal to the object dot name. You can use this syntax to set the values of those keys in the object. You can use this notation to store what the value is in that object with that key inside this variable. And then bracket notation, they're similar and equivalent. So you access the name key inside the object, and you set the value equal to then Simon. And then you declare a variable named name, and you set that variable equal to the value of what is in the name key inside the object. You can also use a variable to define a key, which we're looking at here. So const user is equal to prompt, what is your key? And then you access the object, or if it's not there already, create a key with the string that was stored in user, and then you set that value inside of that key equal to the prompt, what is its value, and the user's input then. These are also semantically equivalent. The second method has the advantage that the name of the property is provided as a string, which means it can be calculated at runtime. However, using this method prevents some JavaScript engine and minifier optimizations being applied. It can also be used to set and get properties with names that are reserved words. So if you look at the dot notation for obj.for equals string Simon, this will result in a syntax error because for is a reserved word. But if you use obj object and then uses the bracket notation with the string for and set it equal to Simon, it still works. It doesn't return the error. Let's try that out in our text editor here. And let's console.log obj. We'll set that here, set that here. We'll run it. Object is not defined. So we'll let obj equal to an empty object. Now let's try it again. Okay, so I think this ran because of this note down here. Starting in ECMAScript 5, reserved words may be used as object property names in the buff. This means that they don't need to be clothed in quotes when defining object literals. You can see the ES5 specs if you want more information about that. And that's why it did run even with the reserved word of for being used with the dot notation. If we move back here, for more on objects and prototypes, see object.prototype. For an explanation of object prototypes and the object prototype chain, see inheritance and the prototype chain. And then another note, starting in ECMAScript 2015, object keys can be defined by the variable using bracket notation upon being created. And so object key phone type set to 12345 is possible instead of just const user phone equal to new empty object user phone key phone type equal to 12345. And so this is a lot simpler and a lot more efficient than all of this code here. Arrays. Arrays in JavaScript are actually a special type of object. They work very much like regular objects. Numerical properties can naturally be accessed only using the square bracket syntax, but they have one magic property called length. This is always one more than the highest index in the array. So one way of creating arrays is as follows. const a, the variable a, is equal to new array with a capital A and then the parentheses method. And then you can set the values of a as the array at index 0 is equal to dog, a at 1 is equal to cat, a at 2 is equal to hen, and then you find the a dot length, and it is equal to 3 since the highest index is 2. A more convenient notation is to use an array literal, which sets the variable equal to the square brackets and the things that you're putting into the array directly in one line. And then as you run a dot length, it still returns 3. If we want to see this in action, we can see this in action down here. And then if we console log the length of a, or if we console log a first, and then let's do this, and then a dot length, we will get that we will get the literal things that are inside the array first, and then we'll get the length of it, which is 3. But note that array.length isn't necessarily the number of items in the array. If you consider the following, if you look at const a, dog, cat, hen, and then set the value at index 100 equal to fox, which let's just copy this line here and add it into our array here, and then console.log a, and then console.log the length as well, we'll see that it returns dog, cat, hen, 97 empty items, and then fox, and the length returns 101. So remember, the length of the array is not the amount of items that are in the array, but the length of the array is one more than the highest index in the array. If you query a non-existent array index, you'll get a value of undefined in return. So if we do type of a at index 90, it will return undefined. Let's test that out real quick. So console.log a at index 90, and then run it, and it is undefined, just like they say. If you take the above about square brackets and length into account, you can iterate over an array using the following for loop. For let I equal 0, I is less than a.length, I increment by 1, and then do something with the a of I. ES 2015 introduced the more concise for of loop for iterable objects such as arrays. So if you use for const, setting the variable to current value of a, and then tell it to do something with the current value, you can use that as well. So these are functionally equivalent. While the variable being set to current value here, instead of the variable being set to I up here and incrementing it. And so let's test that out. Let's try this code first. Putting that in here, and then we'll use, we'll just console.log the things that are inside a for the index of I. And then we'll leave those, we'll delete these, but we'll leave all the array things alone. And it prints out all of the different undefines after it prints out dog, cat, hen, then all the undefines, then fox. If we copy this code, but then we change this to value, let value in a, and run it one more time, clear this, run it one more time. I is not defined. Oh, that's right. We have to set this to value. We get dog, cat, hen, fox. You could also iterate over an array using a for in loop. However, this does not iterate over the array elements, but the array indices. And so if we test this out one more time, instead of accessing a with square bracket value, let's try printing out and console.logging just the values directly. And so there we get, using the in method, we get index of 0, index of 1, index of 2, skips over all the rest of the indices since there's nothing in there, and then goes directly to index 100. If we use the of instead of the in keyword here, and run that, that gives us all of the elements that are inside the array, including all of the undefines. So there's the difference between the for of loop and the for in loop, which they don't have an example of the for in loop, but we just went over that. So if someone added new properties to array prototype, they would also be iterated over by such a loop. Therefore, this loop type is not recommended for arrays. Another way of iterating over an array that was added with ECMAScript 5 is for each. And so for the array dog, cat, hen, they run the method for each. They declare a function, give it the current value, the index, and the array, and then they say do something with the current value or array of index value there. Since for each is well documented and they're already giving some examples, we'll just keep going in our tutorial here. If you want to append an item to an array, you do it like this. You access the array in the variable a, you use the dot push method, and then you pass into that dot push method the item that you want added onto the end of the array. Arrays come with a number of methods. See also the full documentation for array methods. For each of these array methods for JavaScript are well documented. There's a lot of videos out there. You can go watch any of those for those. We'll not be going to give code examples of these, but we'll just be going through reading each of them. If you use a or array dot toString, this returns a string with the toString of each element separated by commas. A dot toLocalString returns a string with the toLocalString method of each element separated by commas. A dot concat, and then gives if you give the items, item 1 through item n, that you want to be concatenated onto the end of the array, returns a new array with the new items added onto the previous array that you were accessing. So array of dog, cat, hen, and then concat with new items would return an array of dog, cat, hen, and then those new items on the end. A.join with the separator converts the array to a string with values delimited by the separating parameter. A.pop, this removes and returns the last item from the array. A.push, we just went over that, appends items to the end of the array, whatever those items are. A.shift removes and returns the first item from the array. A.unshift prepends items to the start of the array. And so this, you can use A.unshift to put items at the very beginning of the array, however many items those are. A.slice returns a subarray. And so that takes I believe that's non-mutating for the original array, but it returns a new array with just those items that are there that you are trying to access from the start to the end. A.sort and takes an optional comparison function and sorts the items that are in the array based on that comparison function. A.split, or I'm sorry, A.splice takes a starting index, takes an amount that are to be deleted from that starting index, takes items if you want to replace the things in that starting index. This lets you modify an array by deleting a section and replacing it with more items. A.reverse reverses the array. Now, moving on to functions. Along with objects, functions are the core component in understanding JavaScript. The most basic function couldn't be much simpler. Function add with parameters x and y, and then create a variable called total and set it equal to x plus y, and then return the value of that variable total. This demonstrates a basic function. A JavaScript function can take 0 or more named parameters. The function body can contain as many statements as you like and can declare its own variables which are local to that function. The return statement can be used to return a value at any time, terminating the function. If no return statement is used or an empty return with no value, JavaScript returns undefined. So if we copy this code, we simply paste it in here, and we do this basic function of add x and y, and then we pass in with calling the function 5, and then the second argument 15, it should return 20, but let's give it a printout statement, console.log, to be able to see that for sure. So as we run this code, it does return 20. Now, the syntax for this is the function name, the name you're giving to the function. I'm sorry, this is the function keyword, the name you're giving to the function, and then the parameters you want to use in the function, and within the parentheses here, separated by a comma, and then using the curly braces as the beginning and the end of the function. Functions are called using the name that was given to the function, and then the parentheses and whatever parameters that are to be used inside the function inside those parentheses, which is how we used 5 and 15 as x and y here. You can't perform addition on undefined, by the way. You can also pass in more arguments than the function is expecting. So if you pass into the add function 2 for x, 3 for y, and then 4, it will still return 5 because it will only operate on 2 and 3 for this function. The name parameters turn out to be more like guidelines than anything else. You can, it says up here, you can call a function without passing the parameters it expects, in which case it will be set to undefined, and will return undefined. So let's try that here. We'll move down here. We'll delete these. We'll run it again, and returns 20, returns not a number. As we use add 2, 3, 4 in here, 5, 15, let's add 20 to this function call here. We return 20, 20, not a number. This may seem a little silly, but functions can have access to additional variable inside their body called arguments, which is an array-like object holding all of the values passed into the function. Let's rewrite the add function to take as many values as we want. So let's copy this. Let's go in here. Let's just get rid of all of this so that there's nothing clogging our screen. And let's look at what's going on here. So we call add 2, 3, 4, 5. Print that out. And what do we get? 14. 2, 3, 4, 5. So it adds 2, 3, 4, 5 because the inside the function, it's setting a variable sum equal to 0. And for each item that's in the array-like objects of arguments, it's increasing the sum by the value of whatever that item is, and then returning that sum. And so since 2, 3, 4, and 5 is passed in, it's adding all of them and returning the value, which is 14. As we move on here, that's really not any more useful than writing +2, +3, +4, +5, though. So let's create an averaging function instead. So it creates the function with the name average or AVG, and select this, paste it in here, and let's console.log that and see what it gives back. And it returns the average of 3.5 for those values. This is pretty useful, but it does seem a little verbose. To reduce this code a bit more, we can look at substituting the use of the arguments array through REST parameter syntax. In this way, we can pass in any number of arguments into the function while keeping our code minimal. The REST parameter operator is used in function parameter lists with the format ... variable. And it will include within that variable the entire list of uncaptured arguments that the function was called with. So using this new function syntax, function average, with parameter passed in all of the arguments, so ... args, let sum equal 0 for const item of args. And so let's just copy this code rather than going through, let's see, is there any difference here? Let sum equal 0 for const item of args instead of arguments. Sum plus equal item, return sum divided by arguments.length. And this is return sum divided by args.length. And so if we delete all of this. The function name is still the same. We just change this to args, and then we console.log the function call with these values passed in, and then we run it. We still get 3.5. But now if we change the numbers that are inside this function call, include 6, 7, 8, 9, 10, and run it again, still runs and returns the average, which is now 6. In the above code, the variable args holds all the values that were passed into the function. It is important to note that wherever the rest parameter operator is placed in a function declaration, it will store all arguments after its declaration, but not before. So, i.e., a function average first value, comma, ... args will store the first value passed into the function in the first value variable. So first value will be stored in here, not in here. And then the remaining arguments get stored in the rest variable, args. That's another useful language feature, but it does lead us to a new problem. The average function takes a comma separated list of arguments. But what if you want to find the average of an array? You could just rewrite the function as follows. So function average array, pass in the array, let sum equal 0 for const item of array, set the sum equal to the current value plus the value of the item, then return sum divided by the length of the array. And so passing in the array 2, 3, 4, 5 returns the value of 3.5 for the average. But it would be nice to be able to reuse the function that we've already created. Luckily, JavaScript lets you call a function with an arbitrary array of arguments using the apply method of any function object. So for the function that was set to the variable average, you can use the apply method to that function and then pass in null for the first argument for the apply method, and then pass in the array as the second argument for that apply method, and it will return the 3.5 value as the average. The second argument to apply is the array to use as arguments. The first will be discussed later on. This emphasizes the fact that functions are objects too, like we said at the beginning of this tutorial, looking at functions, looking at objects. Everything in JavaScript is an object. So you can achieve the same result using the spread operator in the function call. For instance, average, calling the function, and then using ... numbers. So moving from the top back to anonymous functions as we come back, when we were looking at all of these different data types in here, functions were listed underneath objects because functions are objects in JavaScript. So just pointing that out there. So as we go to anonymous functions now, we will finish functions in this video, and then the next video will be for all of the other categories that are inside this tutorial with custom objects and closures. Anonymous functions. JavaScript lets you create anonymous functions, that is, functions without names. In practice, anonymous functions are typically used as arguments to other functions or are made callable by immediately assigning them to a variable that can be used to invoke the function. Note that there's no function name before the parentheses. So let average, declaring the variable avg, equal function, and then setting the function equal to let sum equal 0 for const item of arguments, sum plus equal item, return sum over arguments.length. That makes the anonymous function invocable by calling avg with some arguments. That is, it's semantically equivalent to declaring the function using the function avg parentheses name function form. But there's a way that anonymous functions can be useful even without ever being assigned to variables or passed as arguments to other functions. JavaScript provides a mechanism for simultaneously declaring and invoking a function using a single expression. It's called an immediately invoked function expression, or IIFE, and the syntax for using it with an anonymous function looks like this, where you use parentheses first to use the function keyword, parentheses for parameters that might be passed into that function, and then the curly braces for the code that will be run inside the function. Further details on IIFEs are out of scope for this introductory article, but a good example of what they're particularly useful for is in the emulating private methods with closures section of the closures article. Now, moving on to recursive functions. And we're going to stop there for right now, take a short break, and we'll come back with the next video.